everyone. We are in statistical analysis. We are looking at bivariate data analysis, MS4. And again, we are looking at the equation of least squares line of best fit. So in the previous video, which was number 4 of bivariate data analysis, we also looked at the least squares line of best fit. So if you haven't looked at that one, I would recommend having a look at the previous video because we go into detail and we show on the calculator how to find the SX, SY, and the mean of X and mean of Y values. This slide here is just a revision slide showing what the two main formulas are. This one here with the M, the gradient, and this one here with the Y-intercept, because we here are about to do a question. So that was just to show you what the formulas were because we're about to use them now. So if we have a look in this question, the table below shows the heights, centimeters, and masses, kilograms of 9 people. So there are our two variables, heights and mass, and I'm just going to quickly write on X and Y. And our first job is to find Pearson's correlation coefficient. So I'm going to do that here. And if you remember from the previous video, to find Pearson's correlation coefficient, the first thing you have to do is you have to put the values of the table of values into the calculator. And so we're going to do that now. We're going to do press mode setup. It will come up with all the different options, and we want to press 2 to get into stat mode. Once you're in stat mode, it will come up like this, and we want that option there, the A plus BX. So press 2 again, and it will come up with 2 columns, an X and a Y column, and we're going to put all the values from the table of values into these columns. And when you do that, you just need to remember that these are they're all ordered pairs. And so they need to correlate with one another. So where 163 is in the X column, you need to make sure 55 is in the Y column next to it. So let's go and put all those values in. We have 163, 165, 170. We have 175. So I'm just putting all the X values in, and then I'll go across and put all the Y values in. And I'll just check the X values as I put the Y values in to make sure that they match. So when I have 163X, I have 55Y. When I have 170X, I have 64Y. So it's a little tedious, but it gets the job done. And once you've put all the values into your columns, you can press the orange AC button, and there should be a 0 down in the corner. That indicates that we're in stat mode, and any calculations we do will be based on the values that we just put in. So once we've done that, we can go, and our second step is press Shift 1. So once you press Shift 1, it will come up with all the different options, and we want to go into option number 5, which is reg. Oops. Once you go on into option number 5, it'll come up with these, and we want Pearson's correlation coefficient, which, if you remember, is R. And so you press the one that has the R symbol next to it, which is number 3. Once you press 3, press equals, and it should give you 0.9743. I'm just going to do that. 0.9743. There was more values after it, but I'm just going to round up to that. So that's how we find Pearson's correlation coefficient. using those 4 steps there. Once I've done that, I'm going to erase this so I have more room for question B. Question B says, use a calculator to determine the equation of the least squares line of best fit. So when I am doing question B, I am going to keep all the values I put in question A. So by checking that, I still have a 0 there, which means I still am in stat mode, which means all my values are still there. If I was to clear it by pressing Shift 9, 3 equals AC, then I would have to re-enter all my values. So I don't want to have to re-enter all my values, so I'm just going to do it all in one go. And so I'm going to write down all the possible things that I need to find. So we have our standard deviation of y, standard deviation of x, the mean of x, the mean of y, and then I'll also need to get my gradient and my y-intercept. So let's go and find these 4 first. So by doing that, you press Shift 1, then you press 4, and it will come up with all the options. If you actually have a look, you can see SY down the bottom there, and you can see SX there, the second option. So we're going to go and find those. SY by pressing 7, and you get 7.089. And then you press Shift 1 again, and we go 4, and then we want 4 again, and we get 9.194. Then I'm going to do Shift 1, 4, and I'm going to get 2 for the mean of x, and then Shift 1 for 5 for the mean of y. Now once I've got all of those values, I'm going to clear my calculator, because then I can solve for m and solve for the y-intercept, but you don't want to solve for those two based on our table of values. We want to solve for them based on our new values that we found. So we need to clear the calculator by pressing Shift 9. Then it will come up with these 3 options. You press option 3, then you press equals and AC, and then your calculator will be blank. Now we can solve for m, which would be m equals r sy over sx. So we can go m equals r, which we calculated in step A, 0.9743 times sy, which is 7.089 over sx, which is 9.194. And when you put that into your calculator, you should get a value of 0.7512. Once you've done that, we can then go and solve for C. And if you remember, C is the y-intercept, and it equals the mean of y minus the gradient times the mean of x. So then C equals 67 minus 0.7512 times 176.56. And when you solve for that, you should get a value of negative 65.63. Now we've got all the information we need to solve for the equation of the line in gradient intercept form. So we are going to do y equals mx plus c. I'm just going to draw a line there. So therefore y equals m, which is 0.7512 x plus our y-intercept, but our y-intercept is a negative, so then it'll be negative 65.63 as our final answer. So these are our steps. I'm just going to quickly run through them. The first step would be to solve for these by putting the table of values into your calculator and then finding those 4 values. Our second step would be to find m. And our third step would be to find the y-intercept. And then finally, our final step is to solve and put sub m and the y-intercept into the final gradient intercept form equation. Step 1, step 2, step 3. Whoops, that was a very bad 3. 3. And step 4. So that's how you would calculate the least squares line of best fit. You would find all the values you need, sub those values into the 2 equations that we have, and then sub the answers of those 2 equations